In section 11, topic 6, we're going to be looking at the volume of pyramids and cones. This is the general formula that we're going to be using. So the volume is 1/3 of the base area times the height. And just like it did in surface area and volume for prisms and cylinders, the formula is always going to change depending on whatever shape the base is. So we're going to use 1/3 and the height, but this base area part, that's the part that changes depending on what shape we have. So if you look at this first figure that I've drawn, the base shape is a rectangle. So we'll need to calculate the base area of this rectangle. So for area for a rectangle, it's just base times height or length times width, whatever you'd prefer. So we're just looking at 25 times 14. So the base area ends up being 350 inches squared. Now we do already have the height. So the height of the figure is going to be the perpendicular line to the base. So it's going to be this invisible line or invisible line inside the figure that is perpendicular to the base. Sometimes this won't be given. If this isn't given, you'll have to use the Pythagorean theorem. But in this problem it is. So we know the height is 22. So in order to calculate volume, we're using the formula. Volume equals 1/3 the base area, which was 350, times the height, which is 22. So lastly, we're just typing this into the calculator, and honestly the best way to do this would be to do 350 times 22 divided by 3, because multiplying by 1/3 and dividing by 3 is the same thing. So when I do that, 350 times 22 divided by 3, I get 2,566.67 inches cubed. In our second example, we have a cone. So the base that we're going to use is a circle. So again, like I was talking above, the volume formula is going to change depending on what kind of shape your base is. So above with the square, we use length times width or base times height to find the area of the base. For a circle, you have to use pi r squared. So the base area for this cone is pi, which we're going to use 3.14, times 9 squared, and that's going to be our radius squared, pi r squared. So the base area is 3.14 times 81, which is 254.34. The tricky part about this problem, and I was talking about it above, you need the height of the cone. This is not the height of the cone. This is the slant height, which is different. The height is always this perpendicular distance from the base to the top, or to the, in this case, the bottom of the figure. So we need to look for A. Since it's perpendicular, this forms a right triangle. So we are going to use the Pythagorean theorem to solve for A. So we're looking at the height, which is going to equal, or we're going to find it from the Pythagorean theorem. So A squared plus B squared equals the hypotenuse, or C squared. So I'm going to do 19 squared, I'm going to subtract 81. And when I do that, I'll have A by itself, so A squared will equal 280. I'm going to square root both sides. And A is going to equal 16.7. So this height for A, that's the height of the figure. So when I plug that into my volume formula, volume equals 1/3 the base area, which is 254.34, times the height of the figure, which we just found was 16.7. Again, I'm going to multiply 254.34 times 16.7 and divide by 3. So volume equals 1,415.8 centimeters cubed.